Karthik.
I'm Ben. Yeah, so our project is about smart property and implementing it. Yeah, so smart property, I'm sure you all know this because of our class, but for those who may not have been paying attention, essentially it is placing the ownership of some property on the blockchain and making it tradable through non-falsifiable secure means. So Keji's going to put a transaction on the blockchain right now, actually, because we want to go ahead and get it on there so that we can, so that somebody can mine a block real quick and we can get our presentation over with.
Before Keji does that, what we've effectively done is we've taken this, which is the property, which is a Raspberry Pi, we've effectively put it on the blockchain. AKA, so basically this Raspberry Pi is connected with some address on the blockchain. Whoever controls those Bitcoins associated with that address controls the Raspberry Pi. So we've already initialized this Raspberry Pi for the sake of this demo. So if Keji press like get address, it'll pull up the address, and he can also open the Raspberry Pi. So what happens is the Raspberry Pi, when it's booted, it starts a lock script, and it can only be unlocked by providing the signature associated with the nonce that it provides to the owner.
Yeah, so since it's a nonce, and I'm just gonna put the private key in, it signs it, and now we wait.
And right here, which the Raspberry Pi is operating, it should unlock the Raspberry Pi and allow it for use.
Yeah. So.
It takes a little sometimes.
Lock.
Yeah.
So what happens is, so that's basically what happens when an owner wants to.
So now Keji's going to put a transaction on the blockchain so that someone will mine a block. Yeah.
Increase the font of your browser, as in zoom out your browser. It's not visible in the camera.
Oh, zoom in. Yeah.
So what we're doing right now is basically we're going a little fast right now just because we want to get this transaction on the blockchain and get it on a block so we can show how we change ownership.
Yeah. So if anybody has any friends in any mining pools, tell them to hurry up.
While we're waiting for it to confirm on the blockchain, we're going to sort of go through the steps of how we develop this and how we implement it smart property and the specifics. So.
Yeah. So don't worry about it. So sort of just to give you a little background of the theory of smart property, like we said, it's putting ownership of property on the blockchain. The idea is that it's unfalsifiable, it's non-refundable, it has all the nice properties that Bitcoin transactions have. It has anonymity if you would like it, and it's the sort of the critical nature of it that separates from a normal Bitcoin transaction is that it's you do both the exchange of money and the property in one transaction. So it's called an atomic transaction. So if you sort of see here what we're doing, did you go ahead and broadcast it yet? No.
Wait.
Okay, there it goes. Okay.
Boom.
So now we're going to run through it again. If you see what we're doing, we're actually making a transaction with 2 inputs and 2 outputs. Or it's really 1 plus n inputs where you have a certain number of UTXOs that you're using. But the simplest case is 2 inputs, 2 outputs. One of the inputs is the property, which has some associated number of Bitcoins, which is usually a very small number because you're essentially burning those Bitcoins because they're associated with the property. So really the valuable thing is the property, not the Bitcoin. So we put like a cent on it or something. The other input is the payment. And the outputs are a new property, which has a new address and everything, a new private key, and the payment going to whoever sold it. So, Keji, why don't you go to the transaction screen?
Yeah, so I did it really, really fast, but let me take you back slower. So right here we have, transaction screen. And so this is all live and in real time. So what happens is, okay, so you have a buyer. Okay, I'm gonna start listening to what happens, if any sellers gonna come on.
Yeah, just a point of order. There's 2 tabs here,
Yeah,
which is why it looks like he's refreshing really quick. He's switching back and forth.
So this is so on the second tab right here, I have the buying screen. Right here, I have the selling screen. So right now, I'm gonna start selling something, and so I can put a lock, put some kind of. Right now, since I'm not gonna actually make a transaction, whatever address is not gonna matter. I can do something like that. Put some price in Satoshi. send it. And yeah, so now I'm gonna wait on the buyer. So if you go back to the buying screen, it pops up. Now it starts listing the sellers, and then I can put my own address. So if I say I just put some random address here, and so from this payment address, I'm gonna start querying the UTXOs from, and sometimes it takes a while.
Are there even UTXOs in that address?
It should be.
Okay, but
if it doesn't,
ooh, live demos, guys.
yeah, yeah. I mean, if it doesn't have any UTXOs, it just wouldn't show anything. But you probably have seen before, like when I actually made the transaction, you saw 2 UTXOs listed, and then you can just select which ones you want to pay from.
Yeah.
And then once you select those UTXOs, you can put the private key for the buyer side, and once the buyer enters that, the seller has the option to put his private key for the property.
Yeah. So in general, this kind of thing is extendable not just to some little Raspberry Pi that we configured, but a whole sort of world of things. Like I think the canonical example that's given in the Bitcoin wiki is a car, and you can sort of imagine this kind of thing where there's a protocol where the seller who has a car would say, okay, you went to buy a car, he generates a nonce and a bunch of data or something, gives it to the buyer, or then the buyer generates a nonce, gives it to the seller, who puts a bunch of data and the nonce and signs it with the car's private key. So the buyer can now verify that, one, this address has the car associated with it, and that it has all these properties. The next thing that happens is that they go into this transaction. They do the sort of protocol we did, where you have the buyer gives a public address they would like to pay from. The seller puts on a price and a receiving address. They enter these into a transaction, and then they each take turns signing it.
So we talked a little bit about the transactions, but there's been a lot of the Bitcoin forums and development out there. They sort of have been trying to sort of figure out, what are we going to do for this transaction? How are we going to represent property on the blockchain? So once we sort of figure out that we can just associate a property with an address, we wanted to actually build a property and sort of show the full stack how it's going to work in action. So what we did was we took a Raspberry Pi and said, okay, we want to put this sort of quote-unquote computer onto the blockchain. So whoever owns these Bitcoins owns the computer and can access whatever's in the computer. So we modified the boot script to run this Python script at the very end, and so the Python script would run a server, and the server can communicate with whoever calls its API. So the API has a bunch of different functions, and the lock has already been initialized, but if it hasn't, you can initialize a lock, or you can initialize whatever address you want the lock or the Raspberry Pi to be associated with. You can also change the ownership of the Raspberry Pi. You can get a nonce from it. You can verify the nonce. You can finally open the Raspberry Pi. So what happens is the Raspberry Pi it turns on and it just waits, and it'll wait forever, and it'll wait until somebody reaches out to it, just like a car would. And once somebody reaches out to it, just as we showed initially, it'll say, what's the address of this Raspberry Pi, and it'll respond with the current address. And eventually, as we're going to show right now, we've already done this transaction. Actually, luckily, it just made it onto a block.
Yes.
And
So this is the new ownership.
and so for now, for this demo, we've set the Raspberry Pi to say that we don't want any proof of work. We just want it to be in a block, and then the person and the transaction, if it's in that block, then we can open it. But normally, under normal circumstances, we'd want to have some proof, some work on top of that block, maybe 3 or 4 more blocks, so that the computer knows that the transaction won't be reversed later on. But for this demo, now we can actually see that the Raspberry Pi has a new ownership address. So now if Keji goes back to the initial, if he wants to open up the Raspberry Pi right now.
Did you want to?
Oh yeah, well first things first, if you have a new property, you would want to hit initialize, and then you would put in a address to pay from. You would go through this and a change address. You go through the same sort of interface where you select some UTXOs, and it pays you. You pay money into the property, and you get to choose how much you want to put in.
Yeah,
We actually take care of generating the property address for you. if only because we tried to make this a little bit more user friendly, and I think the average user of this isn't going to want to figure out how to randomly generate a Bitcoin address, keep their private key, put it in.
Yeah.
And we actually output both the public address and the private key, and mentioned that you should save it.
So like when I created the transaction earlier, you saw how I copy pasted the public and private key and put it on my test.
Yeah. Okay, so
let's go back
go to unlock. So if you close the get address, you probably won't be able to tell because it's pretty small, but it will have changed.
No, it shouldn't have because it didn't update yet.
Oh, it hasn't not updated?
Yeah, I know. So it'll.
Oh, it hasn't changed.
Yeah. So once you open the Raspberry Pi, if Keji tries to open the Raspberry Pi with the private key associated with the address that popped up, it's not going to work because the lock has updated to a new address once we try to sign it. So we haven't
that's right.
couldn't figure that once you try to verify a message, it updates the lock first based on by checking the blockchain to see if the UTXOs associated with the address that it has right now has been spent. If not, then it will open the lock, or it'll update the lock, and then it'll try to sign it still. It'll still try to verify the message, but it's not going to work because the address has been updated. So
Right.
if Keji tries to sign the
So yeah, if we use the same, so try and sign it with the old private key.
Yeah. So if I try to sign it with the old one, okay, so it's sent to the nonce. So this is the old private key that worked before when we first started this demonstration. But now if I try it,
We'll wait for a while and nothing will happen, which
nothing will happen.
which is
So because
Yeah.
nothing's happening, we know it's like not working.
right.
However, let's try unlocking again.
Well, no, for now try and hit get address, so that depending how long that script runs, should be different. And the reason of that is that we actually, again, like Karthik said, we actually update it when you ask for the nonce. That's when we update the address that it has. And we do this by that thing has an internet connection and actually reads the blockchain, and it knows its old address, and so it looks for transactions with that and updates accordingly.
So then it just takes a while for the whole
Yeah.
connection.
A little slow Wi-Fi. But good.
And they just gotta refresh
Yeah,
the whole
server issues.
server.
So you have
Yeah.
Bitcoin D running on the Raspberry Pi?
No, we actually have. So we didn't use Bitcoin D at all. We
Okay,
used
what
our separate libraries.
Uh-huh.
So the Raspberry Pi, we wrote, because we're writing scripts and things, we wrote in Python.
Uh-huh.
And so that's using
uses
blockchain.
blockchain info API
Okay.
to get
Yeah,
the
to
get
draw.
the block. Yeah.
The website has, like, the server we run is a node, and so we have a JavaScript sort of skeleton on that, and so we used a couple different libraries, the main one being Bitcore, which has a pretty good library. The only thing that is tough on there is it's really hard to sign a nonce. So we actually just grabbed another JS library called Bitcoin.js, and we use that for the sole function of signing a nonce with a address. And the Raspberry Pi, when it verifies the nonce, actually uses a Python library called Bitsig,
yeah.
or something? Yeah, Bitsig,
Just a sort of
So-
amalgamation of different
Yeah.
libraries. Yeah.
pretty much. Still having server issues.
Yeah,
Crazy.
having server issues.
Yeah, it's just like some.
Yeah, that's fine.
Yeah.
So while you're figuring that out, I have some more questions for you.
Sure.
Or if you guys have
Yeah.
questions, you're welcome to ask.
Well, I have a clarification. So you said it's talking to blockchain.info's API, so it's basically acting as an SPV client with blockchain.info, giving it the current UTXO set and
Yeah, exactly.
Yeah. We use Blocktrail.
For the
Yeah,
JS, we
yeah,
use
for
Blocktrail.
JS,
Yeah. When we grab the UTXOs, if you enter an address, that's using actually something called, which has JavaScript library, and it's actually it's pretty nice to go to instead of, like, I like it better than Block Explorer, if only because it shows unconfirmed transactions, which is nice. When you put a transaction, you can actually see whether it has heard about this transaction or not, and Block Explorer does not do that until block comes.
So on the
Thanks.
Raspberry Pi, do you do anything to verify that blockchain.info is not messing with you when it returns responses to your API calls?
No,
So, well,
Or
not
or
really.
somebody who's on the network is
Yeah. So
replacing
what we,
all the...
So all we do is the transaction's valid. So
Uh-huh.
we follow the block. So we follow, unless blockchain info has forged the entire history of the transaction, then we verify it each time we go backwards. So
Sure.
In
but you
particular,
check
they'd
the
have to.
proof of
I
work
mean, they'd
for-
have to sign it with the private key that we have. So if they were able to broadcast a valid transaction, including a signed,
I did.
our signed, sort of, I guess our address, sending the property bitcoins away and
Uh-huh.
signing it, then I think we would accept it. So I think it is vulnerable to some spoofing attacks,
Okay.
but it's sort of unlikely that they're going to be able to forge our private key, I would say.
What about
What about the upside?
Yeah.
what about a blocking attack where like Alice tries to sell to Bob, but blockchain just says the transaction that gave it to Alice originally hasn't been redeemed?
Yeah, I mean that's a viable attack on our system,
I guess a better
I-
way to circumvent that would be to use call from multiple different APIs.
or just to run Bitcoin D and do it ourselves. But it's
But then you need a big hard drive attached to that.
right, exactly. It's especially for this kind of project where it's mostly just implementing it in proof
Yeah,
of
no, that's
concept.
fair.
We sort of accepted that and said
Yeah.
we'll trust blockchain this time.
So here's a trickier question. So you have this web interface with buyers and sellers,
Yeah.
and the seller goes there and puts something up, and then a buyer comes and is looking at a picture of a lock or a bicycle or a car or whatever is being sold, and the website says this is the address corresponding to this. How
Right.
does the potential buyer know that the website is not just messing with you, that address actually corresponds to the object that it's displayed next to?
So what would have to happen is that the user would send the lock a nonce, and then the nonce would and the lock or like the whatever product it is would have some sort of data structure associated with it that has all the information that's not corruptible, I guess, by anyone else. And then they would take the nonce, sign the data structure with that nonce, then send it back to the user so the user knows it's not like a replay attack of like a previous instance of that data structure's sending, and then the user can verify that the product is what.
When you say user, you mean buyer.
Yeah, the buyer.
So they have to execute a protocol with the
Exactly.
Yeah.
property before.
And
Right.
actually
we
making
haven't exactly implemented that on here.
It is
Um,
so it's connected.
And actually, what he just said is sort of vulnerable to the fact that if you just have a public key, you can just you could have the information in a public key and sign something without having an actual lock with that information. But we actually put, or at least the plan is, I said we didn't protocol yet, but the plan was to put metadata on the blockchain that actually contains that information or a hash of it or something, and is therefore associated with that address.
So
Right now, we actually just put the index of the property on and we only have one property, so it's easy to keep track of, but on the transaction, which is 0 every time. So if you look on like CoinSecret, you'll just see a bunch of zeros from us,
Yeah, so you
Um,
can go
Yeah,
quick
so
right
you just
now.
go to points.
which is sort of fun.
So this
But-
metadata would presumably would come from the
Yeah, it's
property.
just-
as
it's
opposed
With
to-
us.
Yeah.
That's cool.
Yeah.
That's
Yeah.
nice.
So, but the idea would be that even if it's not, if you put that metadata in a transaction, then someone can look at it and say, oh, this has been traded before, and this data is associated with that address.
So,
So
this is not really criticism of your project so much as just playing out the security.
Sure.
I should say cool project. So are you imagining like that the root, like the fact that this actually is a lock comes from like the factory issues a certificate when it's manufactured saying this private key.
That's kind of where I was going with my questions.
Yeah.
It's actually
Yeah.
this is actually really a
unlocked.
Oh yeah, so you
Oh,
just
you just
put in-
unlock it?
Yeah, he just
Oh.
what?
No, it's just
voices
the standard lock.
It's shoes.
Oh, it is.
It's actually Charlie's.
Extra
No.
credit.
Yeah, I know, but yeah.
Yes, basically, is that it's something that it's with that kind of information, and that's part of the reason we didn't implement the protocol yet. Is that it's really hard to say that it's really hard to prove that information goes with a physical object that also goes with this key, unless you have some sort of trusted authority who made the object.
Yeah. So you need basically the other interesting implication is that implies that the person who buys the object can't extract the key out of it. So there has to be a tamper-proof module that actually has the private key saying that it's really the car it says it is.
Exactly.
Yeah, essentially.
Signed stuff.
Yeah, yeah. So in the future, if we we want to obviously implement a wallet system here, so users can manage their properties and not have to copy paste their private keys. And
But with doing a wallet, we did have to like make a user accounts. And
Yeah, there's a lot of
like,
other stuff to deal with when you do
Yeah,
that.
but-
The other thing that you might notice, just to point out, if you're pointing out flaws in our thing, the other thing you might notice is that on our website you're just like entering in your private key.
Yeah.
That is just like awful. So this is not actually, this would never be a website we'd put out unless we, one, at least made it client side. Right now it's actually on a server, so you're actually sending it to a server, so that's just
But
horrible.
we're storing nothing.
But yeah, trust us, we're doing nothing. But the true benefit of smart property is that it's distributed, and so this idea would be at least client side. And honestly, the better thing to do is get a wallet that can do this and make it something you download on your computer, and so it's nothing. It's all.
I guess so. Just to
sorted out now.
summarize, I guess so. But the goal of our project was basically we wanted to have working implementation of smart property, and just have a proof of concept and say, yeah, this thing works. We made a marketplace for it to show how buyers and sellers can interact, and we showed how the lock, once we put a transaction, how to make an atomic transaction and put it up on the blockchain with metadata, and then have it so that the lock will update or the Raspberry Pi will update, and that the new lock, the new user can now open it. So
Yeah.
to summarize what we've done.
Cool. So just one more, I
Sure.
think, minor correction. It's not that you're looking for no proof of work. It's you're limiting yourself to one confirmation
One
instead of
block.
Actually,
multiple.
Right.
Yeah.
No
Yeah.
proof of work would be just listening to the peer-to-peer network, and as soon as you see the
As soon as-
transaction
right.
going out,
Yeah.
you immediately transfer it.
Yeah, exactly. We're listening for just the one block.
One block.
I wanted to say philosophically, this is really interesting that this kind of vision of the future involves like the blockchain, which kind of techno anarchists really like, plus trusted computing, which is like their least favorite thing in the world.
Yeah.
Yeah.
All right.
Cool. Thank you, guys.
Thanks.
Yeah.